Okay, ladies and gentlemen of geometry, this is 7.2, talking about measuring angles and arcs. So you need to identify central angles, major arcs, minor arcs, and semicircles, and be able to find arc lengths. Now, central angle, this is exactly what it looks like. It is exactly what it sounds like. There is a center, and that is the vertex of the angle. So when you're looking at this and going, this is my arc. This is the angle that matches up to it. So those two are going to be the same measure. Now, it's got to have the center. And it's got to be intersecting part of the circle. So it cuts off part of the circle. It starts at the center, central angle. Sum of central angles, well, if I add 1 plus 2 plus 3, I better add up to 360 because it makes an entire circle. So all angles have to add up to 360. Kind of like in a triangle, how all the angles have to add up to 180, except in a circle, I'll have to add up to 360. So turning around and using that information right away, if I've got these three angles, well, that means 165 plus 145 plus x is going to equal 360. Now it's just a simple algebra equation, so just crank that out. So 360 minus 145 and 165, 145 plus 165 is going to be 310. So x is going to be equal to 50. So that's how big that central angle is. For number 2, I've got 40, 85, x, and this, and don't forget that means 90. So 40, 85, 90 plus x equals 360. So 40, 90 is 130. 130 plus 85 is going to be 215. So x plus 215 equals 360. So 360 minus 215 is going to be equal to 145. So that's how big that angle is. So now, minor arc. Minor arc is the shortest arc connecting two endpoints in a circle. Major arc is the longest arc connecting two midpoints in a circle. And if you'll notice, kind of the difference here, this would be written as A, B, with a little arc over it. This middle one, the long one, would be marked A, D, B, or B, D, A. Notice again with the arc on it. And this is your tip-off that it's a major arc. There's 3 letters there. Semicircle is exactly what it sounds like. It is half the circle. Okay, so it's going to be, you would still say A, B, but you could also say A, D, B, as long as you write it with an arc. So, major arcs are bigger than 180. Minor arcs are smaller than 180 most of the time. Semicircle is going to be exactly 180. So, less than 180, greater than 180, usually equal to 180. Well, semicircle has to be equal to 180. So, GJ is the diameter of circle K. Identify H as a major arc, minor arc, or semicircle. So, GH is there. So, that's going to be a minor arc with a measure of 122. GLH is coming this way, all the way around, GLH. So that ends up being, well, this is 180, and then 180 plus 58. So this is going to be a major arc. And that's going to be adding up to 238. And then GLJ is this one right here. That's a semicircle. That's going to be 180. So now find each measure in the circle of F. So it's kind of like the same thing that we were just doing, except now we got to be kind of clever. Let's kind of take a look here. Let's just take a look at the circle and see what I can figure out. Well, that one's 90. This is 63. If you remember way back when to Geometry A, vertical angles don't go away just because I put them in a circle. So if that's 63, that's 63. So if I take 180 minus 63, that's going to be 117. And then if I take 180 minus 90 minus 63, that's going to be 27. So if I go AED, that's going to be 63 and 90, so that's going to be 153. ADB, okay, so ADB, so that's going to be a whole bunch of stuff. So that's going to be 63 plus 90 plus 27 plus 63. So that's going to be 243. And then if I look at ABD, A to B to D, so that's going to be 117 plus 63 plus 27. And that's going to be 207. So here's the kind of a theorem, and I really hope it makes sense. I think it does. If you're in the same circle or in two congruent circles, two arcs are congruent if and only if their central angles are congruent. Remember, if and only if means it works both ways. So if like 1 is congruent to 2, if angle 1 is congruent to angle 2, then that means FG, that arc, is congruent to arc HJ. It works this way and it works the other way. So if I said, you know what, arc FG is congruent to arc HJ, that implies that 1 is congruent to 2. That tells me that 1 is congruent to 2. So let's look at the graph here to find each measure. So if arc of CD, so that's this arc right here, well, let's look at what I've got. I've got 18%. So what I want to do is figure out what is 18% of 360. So I'm going to take 0.18 times 360 to figure out my answer. So 0.18 times 360 is going to be 64.8. All this stems from the idea that a circle has to add up to 360 degrees. So when I look at here, BC, well, BC is also 18%. So that's going to be the same answer. That's going to be 64.8. So now looking at EF, that's soccer, that's 14%. So that's going to be 14% of 360. So that's going to be 0.14 times 360. So 0.14 times 360 is going to be 50.4. So there's my answer. So arc length, different than measure. Different than measure, okay? Arc measure is going to be an angle measure. Okay, arc length is like an actual length. It's like if you actually walked off this space, this line, how far did you go? So it's going to be equal to the ratio of the degree to 360. So basically what you're going to do is you're going to take x degrees, okay, this x degrees divided by 360, and you're going to multiply that times the circumference, which circumference means just 2 pi r. So that's what you're going to do. Your degree measure over 360 times 2 pi r. So if I figure out the length, and notice it says length. Length. It doesn't say measure. Don't give me an angle measure when it says length. So not angle measure. So if you give me 75 degrees, that's wrong. You have to take 75 over 360 times 2 times pi times 4. So 75 divided by 360 times 8. So that's going to be 1 2/3 pi. That would be an acceptable answer. Or if you really want to multiply it by pi, I suppose knock yourself out. So you'd end up with 5.233 repeating. So either one of those would be fine. So for here, figure out the length of zy here. Now let's change color. So figuring out that, that's going to be 130 over 360 times, now diameter is 10, but I want the radius, so 2 pi times 5. So 130 divided by 360 is going to be 13 over 36 times 10 times pi. So that's going to be 11.3446. There's my answer. Centimeters. All right, so figuring out the length of AB. So here, so 80 over 360 times 2 times pi times 7, or 14 pi, or whatever. So 8 times 14. So it basically becomes 3 1/9 pi, which is fine, or which is a great answer, meters. Or if you really want the decimal, you can multiply by pi, but that's just kind of cheating. Here, dA, so that's going to be 40 out of 360 times 2 pi 4.5. So this is going to be 4 out of 36 times 9 pi. So after all that noise, I end up getting just pi for my answer. So that's going to be pi centimeters. That's all I got. Come talk to me with questions.